Friends, welcome to module 5. Module 5 is dealing with electromagnetic waves. So now we are going to study about a topic known as Poynting'S theorem and Poynting'S vector. So we all know electromagnetic waves, they are propagating through the space, okay, from the origin to a receiving point. Okay. So there is, during this transfer or during this propagation, there is a transfer of energy that is occurring from the source to the receiving point. So this Poynting theorem is establishing a relationship between the rate of energy transfer and the amplitudes of electric field intensity E and magnetic field intensity H. Look at this figure. You can see there is a closed surface, okay, enclosing a particular volume. There is input power and you have the power going out. You can see the power given inside is stored as electrical energy in the form of electric field, and it is also stored as magnetic energy in the form of magnetic flux density B or magnetic field intensity H. And inside the system there will be ohmic laws. Sigma represents the conductivity of the system, and the net power flowing out of the system will be this input power minus the ohmic losses. Coming over to Poynting's theorem, it states that if you have electric field intensity E and magnetic field intensity H, the vector product of these two, that is E cross H, will be giving you the measure of the rate of energy flow per unit area at that point. Note that E cross H is giving you the measure of rate of energy flow per unit area at that point, and the direction of this power flow will be perpendicular to both E and H, or the direction of power flow will be the direction of E cross H. So symbolically we can write the Poynting vector as P, that is equal to E cross H. The unit is watts per meter square by rate of flow of energy per unit area. So P is known as the Poynting's vector. So now, so as to prove this, we are considering the Maxwell's equation del cross E is equal to minus mu dou H by dou T as equation 1, and del cross H is equal to sigma E plus epsilon dou E by dou T as equation number 2. Now take the dot product of equation 2 with electric field intensity E. That is, it becomes E dot del cross H is equal to sigma E square plus epsilon E dou E by dou T. Mark it as equation number 3. Now apply the vector identity to this equation. Which vector identity you are going to apply? Del dot A cross B is equal to B dot del cross A minus A dot del cross B. Here vector A is vector E and vector B is denoted by vector H. So del dot E cross H is equal to H dot del cross E minus E dot del cross H. Now what we are going to do is we are going to slightly rearrange so that you get the term E dot del cross H. We are having E dot del cross H here. So we are going to rearrange this equation number 4. So it becomes E dot del cross H is equal to H dot del cross E minus del dot E cross H. Okay. Now you compare this equation and this equation. Right? So you get the H dot del cross E minus del dot E cross H is equal to sigma E square plus E into epsilon dou E by dou T. Equation 1 in this equation 5. So you get H dot minus mu dou H by dou T minus del dot E cross H is equal to sigma E square plus E into epsilon dou E by dou T.